Every year, the world consumes more than 141 billion cubic feet of wood for housing, furniture, and workspaces. So how can we meet this enormous demand without over-relying on natural forests? The answer is transforming wood waste into particle board. In today's video, Mr. Tech News will guide you through the entire process and explain why recycling wood scraps is so vital. Now, let's begin the journey. Particle board isn't just an alternative material. It's like the Earth's response to the era of climate change. If wood waste is buried in landfills, it decomposes and produces methane, a global warming gas 25 times more potent than CO2. But if it's collected and recycled, this problem is significantly mitigated. For every ton of recycled particle board, we save around 12 mature trees from being felled. This preserves forests, provides a refuge for birds, and maintains the flow of biodiversity. What's more, particle board offers significant economic benefits. Compared to solid wood, it's cheaper and easier to mass produce. Consumers benefit, businesses save costs, and the entire supply chain becomes more seamless. It's a clear symbol of the circular economy, where nothing is discarded as waste, but instead, resources are simply waiting for a new purpose. Now let's join Raw Machines for a deep dive into how this process works. Every piece of particle board starts with what seems like a worthless resource. Dusty sawdust from the corner of a mill, wood shavings from a saw blade, scraps from old furniture, or even planks from dismantled buildings. Typically, softwood is the ideal choice due to its uniform structure and ease of processing. But occasionally, hardwood is also utilized, although it requires more effort and energy. After collection, the wood waste undergoes a purification ritual. A vibrating screen removes dirt, bark, and dust, while industrial magnets extract any leftover nails and staples. This ensures the finished particle board is pure and free of defects. The wood particles are sorted by size. The coarser pieces form the core, while the finer ones are used for the surface layers. From its initial chaotic state, the material gradually enters a new order, ready for its rebirth. When the wood scraps have been cleaned and sorted, they are still rough, with long pieces, short chunks, and sharp, broken edges. To become the standard raw material for particle board, they all must be chipped into uniform wood particles. This is where the massive drum chippers show their power. Inside, alloy steel blades rotate at speeds of 500 to 1,000 revolutions per minute, chopping large pieces of wood into small fragments in just a few seconds. But this isn't just brute force. Right after the chipping chamber, an integrated screen performs on-the-spot sorting. Any particles that are too large are returned for further grinding. Any that are too fine are rejected, as they consume too much adhesive without adding strength. Only those that meet the standard, less than 30 millimeters in size, firm enough and compact enough, are transferred to the drying stage. In a way, the chipper doesn't just grind wood, it redefines its destiny. This is the first step in creating a uniform language so that these tiny wood particles can speak with one voice, the voice of a completed particle board panel. But that's just the beginning. These wood particles are still full of moisture like sponges. If they're taken directly to the press, the steam in the wood would rise, causing the entire panel to blister or even break apart. That's why drying is an essential stage. Inside giant rotary drum dryers, hot air is continuously blown at extreme temperatures from 300 degrees Fahrenheit to 570 degrees Fahrenheit. The wood particles tumble and roll inside, and each layer of moisture is drawn out and turned into steam. The goal is to reduce the moisture content to just 2% to 8%, the ideal balance. Too dry, the particles become brittle and fragile. Too wet, the resin won't bond properly. The entire process is monitored by an online moisture sensor with precise accuracy, which only allows batches that meet the standard to proceed, while the rest are immediately rejected. After leaving the dryer, the wood particles are dry, light, and stable, but they aren't all uniform. Some are too large, while others are as fine as dust. So they must go through one more round of refinement. On the conveyor, the wood particles enter a multi-level vibrating screen system. These massive stacked metal frames vibrate at a continuous industrial pace. The particles roll, slide, and jump through each layer of mesh, automatically sorting themselves by size. Particles that are too large are sent back to the chipper, while overly fine dust is discarded. Only the standard-sized particles are retained and then clearly separated. The finer particles are designated for the surface layers, while the larger ones are reserved for the core. This is the casting call, where each wood particle is assigned its proper role to help create a perfect board. And now, we arrive at the heart of the entire process, the adhesive, the soul of the board. Inside a sealed chamber, the wood particles are coated with a fine mist of resin. This stage is commonly called blending, but it's more like a birth ritual. The resin acts as a new bloodstream, seeping in to cover every fiber, giving them the ability to bond. The two most common types of resin used here are urea formaldehyde and phenol formaldehyde. Urea formaldehyde is inexpensive, easy to use, and provides high adhesion. Like a diligent builder, she quickly getting the job done at a low cost. Meanwhile, phenol formaldehyde offers durability and resistance to water and weather, like a suit of armor for the board. Depending on the final product's requirements, engineers will choose the appropriate resin or blend the two. In addition to the resin, the blending chamber also adds sophisticated additives: wax for water repellency, flame retardants for fire resistance, and antifungal agents for a longer lifespan. Each component is like a craftsman's final touch, upgrading the material to a new level, making it not just functional, but more resilient against the effects of time. Once coated with resin, the wood particles move into the mat-forming stage, where they are laid out into a multi-layered blanket. This technique requires absolute precision. The central core must be thicker and coarser, while the surface layers are fine and thin. To keep the mat from shifting, a pre-press uses hydraulic rollers to lightly compress the entire material. This removes hidden air pockets and stabilizes the structure, preparing it for the final, decisive challenge: hot pressing. The final transformation ritual begins. This is where it's decided whether the wood scraps will truly be reborn as particle board or remain a half-formed block of material. As the conveyor brings the wood mat into the press chamber, steel compression plates weighing tens of tons slowly lower. Inside, pressure can reach 600 pounds per square inch, while temperatures soar from 280 degrees Fahrenheit to over 428 degrees Fahrenheit. Within minutes, the simultaneous force of pressure and heat melts the synthetic resin, so it seeps deep into every wood fiber, then solidifies, bonding the particles and resin into a single cohesive block. The roaring metal, the heat radiating from the machine's edges, and the sharp scent of resin in the air, all of it creates a truly awesome sensation. When the press doors open, light floods the chamber, revealing a complete board, perfectly flat and solid. This is the moment of rebirth. A worthless byproduct has been transformed into a new industrial product, imbued with the strength to serve humanity. But the journey isn't over. The panels are immediately sent to a high-speed trimmer. Whirring saw blades slice away the excess edges and any unstable material. Only panels that meet standard dimensions, typically 4 by 8 feet, or custom sizes for special orders, are retained and proceed. Each cut is both technical and symbolic, by marking the completion of the board's form. If hot pressing was the moment of rebirth, then trimming is the rite of passage, where the product assumes the identity of a new, standard industrial material. Fresh from the hot press, the particle board panels are like red-hot metal bars from a forge. They're searingly hot and filled with internal stress. If left alone, the temperature and moisture differential would cause them to warp, crack, or shrink unevenly. This makes cooling an absolutely essential stage. On the conveyor, each panel, still radiating heat, is sent into a forced cooling line. A massive system of industrial fans blows air from all directions, top, bottom, left, and right, enveloping the entire surface. The airflow doesn't just lower the temperature, it also releases the internal stresses in the panel's structure, bringing it back to a state of equilibrium. In advanced mills, this process includes two-way cooling with integrated thermal sensors. The sensor system continuously monitors the temperature differential between the core and the surface, adjusting the airflow to ensure the panel cools uniformly. The goal is to prevent the outside from cooling too quickly, while the inside remains hot, which could easily lead to cracking. From a distance, the cooling line resembles a long corridor where the newborn panels line up neatly, passing through a fierce rush of industrial air. This moment isn't as loud as the grinding or hot pressing. Instead, it's a much-needed period of calm for the product to stabilize and finalize its form. Once cooled, the particle board is structurally stable. However, its surface is still rough, with jagged fibers and uneven ridges left from the cutting process. Left as is, the panel would be nothing more than a raw industrial block, unfit for modern furniture or construction. This is where the precision sander comes in. A series of massive sandpaper-covered rollers are arranged back to back, spinning at high speed. The panel is fed in, and each roller glides over the surface, sanding away thin layers measured in fractions of a millimeter. A steady, low hum fills the air like an industrial soundtrack. A high-capacity dust collection system operates simultaneously, sucking up the tiny wood particles that are released during sanding. This not only keeps the air clean, but also prevents dust from scratching the panel's surface as it cycles through. The result after a few passes is a surface as smooth and flat as a mirror. You can run your hand over the panel and feel the sleekness, a stark contrast to the initial roughness. This smoothness is the foundation that allows the particle board to be finished with melamine, laminate, or paint, coatings that transform it into the tables, cabinets, and shelving of our everyday lives. This is a testament to the power of technology, the ability to turn something rough into something refined, and to transform a byproduct into a product with aesthetic value. Quality control is the final and most critical step, the ultimate stamp of perfection. This is where human oversight and technology work together to ensure that every single panel leaving the line meets international standards. On the conveyor, each panel passes through a comprehensive laser scanning system. The red beam sweeps across the entire surface, detecting minute cracks, warping, or thickness variations as small as 1 millimeter. These defects are immediately flagged and rejected, ensuring no flawed product reaches the market. Next are the mechanical tests. A random selection of panels is taken to a testing machine where they are bent to measure elasticity, compressed to determine load-bearing capacity, and twisted to evaluate stability. Each data point collected becomes a crucial piece of information, certifying the product's quality to both clients and the market. At the end of the line is the packaging stage. Automatic robots stack the panels neatly like giant bricks, then wrap them tightly in a plastic film to protect them from dust and moisture. A barcode is placed on each package, connecting it to a global warehouse management system. With just one scan, you can pinpoint exactly where and when the batch was produced, and even get detailed technical specifications. But even at this final stage, the story of the environment is still present. Plastic film is difficult to recycle and becomes a burden on the waste system. Therefore, some pioneering factories are experimenting with new solutions. Packaging made from compressed fiber paper or biodegradable film. This proves that the journey towards sustainability doesn't stop at recycling wood, but extends to every aspect of production. And so, from what were once worthless wood fragments, through a series of purification steps and challenges, there finally emerge complete panels. Flat, solid, and uniform. In warehouses, they are stacked like massive blocks, ready to travel, cross oceans and borders, and eventually transform into dining tables, e-library bookshelves, or partitions in a modern office. Completion. It's not just a technical stage. It's the final transformation, where the rough becomes refined, where what was discarded becomes a valuable product. And it is in this moment that the rebirth journey of wood scraps reaches its fulfillment. We've just gone through an incredible journey together. From what seemed like useless wood scraps, through a series of complex processes, they were reborn as millions of particle board panels, an indispensable industrial material in modern life. This is a story about human ingenuity and how we are learning to respect and use resources wisely. While there are still imperfect aspects, it consumes a lot of energy, relies on difficult-to-recycle synthetic resins, and uses unfriendly plastic packaging. These very limitations open the door for innovation. Every scientific advance, every new creation in materials and technology can bring particle board and the entire recycling industry closer to a sustainable future. When you look at a particle board panel, you might only see a flat piece of engineered wood. But if you listen closely, you'll hear the echoes of forests being preserved, the breathing of a climate slowly being balanced, and a message from the planet. Every resource can be reborn if we only give it a second chance. Remember, the story of particle board doesn't end at a lumber mill. It's our story. Thank you for watching until the end. If you also enjoy videos like this, please hit the like button, share, and subscribe to the channel so you don't miss any of our exciting upcoming stories. This is Mr. Tech News, and we'll see you next time.